Okay, let's take the time to go over section 3.7, which is on the elasticity of demand. Okay, and this is a subject that you will use, as you go through your business career, but also possibly on a class project. The first thing that we need to sort of talk about here is this idea of relative rate of change. Okay, so recall, basically in this class we've been dealing with change the entire time, but the absolute rate of change is sort of just the change in the output. So absolute change, the stylus is being kind of a pain here, the absolute change in f as x goes from x to x plus 1 is f of x plus 1 minus f of x, which we know can be approximated pretty well by f prime of x. And so when we look at relative rate of change, okay, this is just relative to what f was. So really we look at f of x plus 1 minus f of x all over f of x, and this gives us f prime of x over f of x. Okay, and if we want to look at percent rate of change, we just sort of multiply this by 100 to get the percent rate of change, because you're going to get probably a decimal here, and then so you multiply it by 100, you get the percent rate of change. Okay, and notice what this takes on. This is the, well, if you look at f, this is 1 over stuff times the derivative of stuff. So really, one way that you can look at this is just the derivative of the natural log of f prime. Or another way that we write this is called the logarithmic derivative. Okay. Alright, and so with this we can define this idea of elasticity of demand. Okay, so with this we define the elasticity of demand. Okay, if x is equal to f of p is the number of goods demanded at a price p, so x is the number of goods that people will buy, p is the number of price, and remember we sort of have relationships basically like this, or maybe like this. So as price goes up, people demand less of the good. Okay, the elasticity of demand is, we'll call it E of P, which is equal to the derivative of the ln of f of p divided by the derivative of the ln of p, which if you work this out just gives you minus p f prime of p over f of p. And so this is the formula, and you don't have to remember the log definition if all you do is remember the formula to the right here. That is the formula for the elasticity of demand. So as price changes, how elastic is demand? How much does demand change with respect to changes in price? Okay, so let's shrink this down a bit here. Okay, so the elasticity of demand measures how sensitive demand is to changes in price. And so we define a few things. If elasticity is between 0 and 1, we say that demand is inelastic. Oh, that's bad. All right. Okay, so that's one word. So if elasticity of demand is between 0 and 1, we say that demand is inelastic. Namely, if you change the price, the change in demand will not be that particularly big. If elasticity of demand is greater than 1, we say demand is elastic. Okay, so in other words, price changes, demand changes quite a bit when you change price, and if elasticity of demand is 1, we say demand is of unit elasticity. Okay, and that sort of is just a borderline case. Unit elasticity. Okay, all right, let's move on to a different slide here. So another good question, let's go to black again. How does elasticity of demand relate to marginal revenue? Okay, so recall that revenue is price times demand. So remember, this is the amount of goods demanded and then P is price. Okay, and we know that the number of goods demanded is f of p, right, a function of the price. And so if we take the derivative of R with respect to P, we use the product rule. You get f prime of P times P plus f of P times the derivative of P, which is just 1. Okay. Factor out an f of P. You have f prime of P, which didn't have an f of P, so when I factor it out, it ends up being divided through. And then times P plus 1. This is just negative 1 times the elasticity of demand. And so here you have f of P, and then here you'll have, let's switch order, 1 minus the elasticity of demand. Okay, so notice here, if we collapse down this formula, okay, how does this work? Well, notice here, this is going to change sign at 1. So if you look at this, if E of P is between 0 and 1, R prime is going to be greater than 0. So revenue goes up when price goes up. If demand is inelastic. Okay, so how do you interpret that from a business perspective? If you can raise price without lowering demand, then your revenue will go up when you raise price. On the other hand, if we look at this formula again, if E of P is greater than 1, then that term is going to be negative, so R prime is smaller than 0, and thus revenue goes down when price is elastic. So if you raise price and demand goes down considerably, demand is very elastic with respect to price, then your revenue will go down when you try to raise price. Okay, and we've sort of been beating around this bush almost the entire class, but this is a very, very nice way to formalize those arguments. Okay, so again, if price is inelastic, you can raise price and still raise revenue. If price is elastic and you raise price, then revenue is going to go down. Okay, so let's do some. All right, so let's do some examples. Okay. Find the elasticity of demand when x, which is equal to f of p, is equal to 10,000 minus 190 p. Okay, and find when demand is elastic and when it is inelastic. Okay, so that's our example. Put that up there, make it a little smaller for us. Okay, well, the computation of the elasticity of demand is fairly simple, right? We take minus p, we multiply it by f prime of p, and then we divide by f. Okay, so f prime of p here is going to be nice and simple, minus 190. And so, therefore, this equation is going to give us minus p times minus 190 over 10,000 minus 190 p. And so that gives me 190 p over and we're almost out of room there, so let's try that again. And we'll just call this 10 to the 4th minus 190 p. Okay? And so to find when it's inelastic and elastic, we just have to set up inequalities here. Okay, so let's do so. Okay, so inelastic if 190p over 10 to the 4th minus 190p is between 0 and 1. Okay. Notice here this is just f of p. We know that the amount of goods individuals have to, or goods that individuals demand is always going to be strictly greater than 0. Okay, so if we multiply all these sides by that term, we're going to end up with inequalities that don't change. Okay, so let's shrink that down a little bit. Okay, so multiplying both sides by that, you have 0 is greater than 190p is less than, or sorry, 0 is less than 190p is less than 10 to the 4th minus 190p. This will always be satisfied if p is greater than 0, so we're good there. Here we're going to have to do a little bit of work. If we add 190p to both sides of this inequality, we have 380p is smaller than 10 to the 4th, or p is smaller than 10 to the 4th over 380, which is 26.3. So if price is less than 26.3 and greater than 0, demand is inelastic. Okay. So that's the condition for inelasticity. Okay. And if we do a similar argument, elastic if 190p over 10 to the 4th minus 190p is greater than 1, we have almost the exact same math. We multiply both sides by the denominator. We end up with this inequality. We add and then we divide by 380 and we collect up. Okay, and we collect up here. We have P being greater than 26.3. So that's when it's elastic. Okay, so in other words, your revenue will go down if your price is above $26.3 and you raise price, and your revenue will go up if your price is between 0 and $26.3 and you raise price. Okay. All right, let's do one more example. All right, let's do one more example here. let X be the demand, f of P, equaling 98 minus 0.6 e to the P. Find the elasticity of demand when P is 1 and P is 5, and determine if demand is elastic or inelastic at these price levels. Okay. Alright, so it's a fairly easy calculation. The elasticity of demand is minus P, f prime of P, over f of P. And so in our case, the derivative of f is minus 0.6 e to the P. And so we write that in there. We have minus P minus 0.6 e to the P, and then over 98 minus 0.6 e to the P. And so the negatives cancel. You have 0.6 P e to the P over 98 minus 0.6 e to the P. And so the elasticity of demand at a price level of 1 is 0.6 times 1 times e to the 1 over 98 minus 0.6 e to the first power, which, if one goes to a calculator and calculates, that's equal to 0.0169, which is in the interval 0, 1. And so here we have the price is inelastic when P is 1. Demand is inelastic. So namely, if your price is at 1, you could raise that price and still increase your revenue. On the other hand, E of 5 is equal to 0.6 times 5 times e to the 5th divided by 98 minus 0.6 e to the 5th, which, if we go to a calculator here, we'll have 49.74, which is greater than 1. So therefore here, demand is elastic when price is 5. Okay, so hopefully, this lecture and these examples will paint a nice picture. Like I said, you'll see these ideas of elasticity of demand and elasticity of other things as well throughout your business careers if you take that path. And so here's sort of a mathematical way of pinning down those ideas. Okay, thank you.